Okay, so today we're going to talk about Newton's law of motion, except here's the deal. I was today minus 1 year old whenever I discovered that, like, a big reason we know about Newton is this chick, Emily du Châtelet. I have no idea how to pronounce this. She's some kind of French person. Okay, so yeah, Isaac Newton. Look, it's that dude. Okay, but here's something really, really cool. Okay, so there's this lady here. She was this French mathematician and physicist. Okay, so what's really cool about her is she translated Isaac Newton's stuff into French because she was a mathematician and philosopher and French person, physicist. She basically took all of what do you call it? Newton wrote and was like, so what Newton kind of meant to say was blah, blah, blah. So, like, her text is still considered the standard French translation to this day. So I think he published it in Latin, maybe? Yeah, it's written in Latin. So again, hey, thanks, dude. You know, you published something super important in a language nobody can understand. And so she, converted it to French, and it was so cool. And she also was super famous for knowing Voltaire. And if you know anything about like French Revolution-y stuff, he was like, probably would have been like the influencer of the day whenever it comes to, I don't know, he's super something in philosophy, Voltaire, and influenced Kant. Or the only thing I know about philosophy I learned from watching The Good Place. But anyway, she was super connected. But she rewrote all this stuff, and it's so cool. So I never knew, first of all, that Newton wrote all of his stuff in Latin. But this is his book, or some version of his book. And this was not the Latin version. This is somebody who's translated it. And one of the things you'll notice, hold on, this is just him talking about the life of Sir Isaac Newton. Let's get to the actual stupid-op. Okay, I get it. Sir Isaac Newton did stuff. Nobody cared. Okay, I'm sure some people care. This dude cared a lot. Okay, so here's the actual book, the Principia. Okay, author's preface. So he obviously would have said all this, but in Latin. Thanks. And so now here's the mathematical principles. So notice how he's got all these mathematical principles. And notice you might not see any math. And there's some, like, geometry a little bit with lots of things, but there's no angle measurements. And, I'm really glad I didn't have to learn physics from reading this, because it's like, here, if this figure, blah, 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 terminated by the right line, blah, 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 and it goes to blah, 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 then it blah, 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 blahs, and you're like, wow, that's really helpful. Okay, so the laws of motion come here. Why did I say page 86? There we go. Page 89, maybe? There we go. Okay, these are his 3 laws of motion. Okay, so, and this would have been written in Latin. Every body preserves in its state of rest or of uniform motion in a right line unless it is compelled to change that state by forces impressed thereon. That's not really like, I was going to say tweetable, but I mean, maybe it is, and people don't tweet anymore, but you know what I mean. Like, there's no math here, and it drove me crazy, because I was like, what was the whole point of, like, I legitimately probably just thought people always used algebra, which I don't even think algebra is that old. If I go to Wikipedia and I just ask it, what is algebra? And algebra started around, is it going to tell me? Maybe. Hold on. When did algebra get developed? I can't spell. Well, popularized, maybe. Oh, well, okay, popularized in Europe. When would Newton have used it? Thank you. History of algebra. Oh, well, there you go. A flood of translations from Arabic into Latin. So, honestly, I'm going to go with Newton had no excuse for not using algebra, because seriously. Oh, but they did have this thing called rhetorical algebra, which instead of saying that, they're like the thing plus one. Yeah, it's so... Descartes, I guess he came like around the same time. Anyway, that's why we have Cartesian coordinates, by the way, is Rene Descartes. Anyway, there's all this stuff that has to happen for us to figure this out. So, I mean, I guess we can give Isaac Newton a pass for, I guess not being totally useless. But, oh my gosh, I would never understand anything from reading this. And I mostly wanted you to know that, first of all, Latin is hard. And then, so this is Émile de Châtelet. And look, this is her original, well, not the original manuscript, but, a reprint. And look, she's got all this algebra in it. And look, that kind of looks like a sine is opposite over hypotenuse, and the hypotenuse is that thingy with a square root, which kind of makes sense. And so what she did is she rewrote a lot of what Newton did, but with math. And she was like, so what he was basically saying is this, and what he was basically saying is this, and da-da-da-da-da-da. And I just think it's so cool because Newton gets all this. I mean, he did come up with it, but it took a lot of people to, like, be able to understand what this meant. Like, this is basically F equals ma. Every stay at rest, the direction of the right line, and with the alteration of motion. Yeah, this one. I think this one is F equals ma. Let's look it up. So Newton's first law is the law of inertia. At rest will stay at rest. Second law is F equals ma. Okay, so if you've ever heard F equals ma, that's what this is. But, I mean, reading this, I'm not going to immediately go, sum of the forces equals mass times acceleration. A double force will generate the double motion. A triple force will generate the triple motion. Yeah, so this is all kinds of fun. Anyway, as we get into this chapter, I just kind of wanted to give you an introduction to the idea that everything we're learning and taking for granted actually took a whole lot of work to figure out, and it's actually super duper cool. And there's all this history if you sort of really want to get into it. So, I mean, I think you kind of understand what a force is you push on something. But a force is also like, right now I am not falling through the floor because the earth is pushing up on me. That's also considered a force. And I'm not flying off the earth because gravity is pushing down on me. Gravity is also a force. That kind of thing. But there were all these like things in Du Châtelet. She came up with all these concepts of like live forces versus dead forces. And I feel like it had something to do, it's really interesting. I think it had something to do with like forces that are like acting on you, and then dead forces are things that are a drive to motion but doesn't produce drive itself. So like it's kind of like, I think, yeah, anyway, so people really argued about how to define these concepts. It's really interesting. So life force, kinetic, dead force is maybe potential energy. So they, even whenever people back then were talking about forces, that was different than when we talk about forces now. So when we talk about forces, we're talking about like literally I push on thing, or that thing pushes back on me. That's what a force is. But, people for a long time, so if you ever at one point are like, I'm kind of confused whether this is force or energy or whatever, that's okay, because people for like centuries struggled with these ideas until everybody finally came together and was like, okay, I think we really know what's going on here. Okay, so one of the things we're going to do is a free body diagram, and that's a huge thing in making sure you've got everything drawn together. It is super fun. The whole idea is you've got like, whenever you're looking at something, there's this big concept about external forces. So like if I'm sitting in a chair just alone, then I'm sitting on the chair is pushing up on me, and then gravity is pushing on me. So it's like, how do I say this? So if I was just doing like a simple picture of me, let me just do me standing on the ground. This is me, I'm on the ground. Then gravity, come here girl, gravity is pushing down on me, and the ground is pushing up on me. Therefore, the sum of the forces in the y direction on me equals 0, so I'm not going anywhere. And it could get more complicated because you're like, well, what about the fact that within you, your head is pushing on your neck? And it'd be like, okay, well, I guess what you could do is you could draw the free body diagram of your body where it's like, so this is force of, I guess I could say weight of body plus head. And then here I could just be like, this is my weight of my body. This is the normal force of the body, or some normal force. I'm just going to call it a normal force. But then on my head, hold on. Yeah, then on my head, there's a weight on my head, weight of the head, which is pushing down on my body, that has the weight of the head going this way, and then that's what I meant to say, like that. And so there's a normal force of the head on the body, and then there's this force has an equal and opposite reaction of a normal force going this way. Basically, these are internal forces is what I'm trying to find. So to make NH plus B, and so this really ends up being this. It doesn't matter. So the point is that if I took my head off my body, oops, there's my cuckoo clock. If I took my head off my body, these two forces are equal and opposite, so they cancel out. So by the time I put my head back on my body, now it's just the regular weight again. So yes, my head is pushing on my body, and then my body is pushing on the ground, but by the time all is said and done, I can simplify myself by saying, yes, my body is on the ground. And in physics, generally, the way we do this is, come here. The way that we do this is we'll just say, pretend I'm a cow, and the cow is spherical. So I won't even draw myself. I'll just be like, this is me. I exist. I have a weight, and there's a normal force keeping me off the ground. Okay, because anything that's like kind of going on inside my body, so stuff might be moving around inside my body, but for the purposes of the apple falling off the tree, I can't assume the cow is spherical. You'll hear me say that like a ton, because it just makes me happy. So I am the cow, I am spherical, and all that stuff that's going on internally, you don't pay attention to anymore. So these are all very, very weird concepts, I guess is what I'm trying to say. And so if at some point your brain is like, this is kind of confusing, that's okay. And that's why I wanted to take just a little bit of time to tell you about the history of it, so that whenever you're looking at this, you're like, oh, okay, I get it. This is actually kind of complicated. We represent forces and factors, shockingly. And then I'm going to do a separate video just on doing free body diagrams, but I just kind of want to give you an idea of like the whole concept of like a force is different than energy, is different than work. And even though we act like, oh, this is super duper easy, like this was definitely like a legit thing that people struggled with. And also I just wanted to give Emile du Châtelet some props for kind of just being awesome, because she was super cool. All right.